Okay, now we are in the period of simple harmonic motion. Okay, the first question. The displacement x of a simple pendulum is represented by the equation x equal to 0.175 cos 7t, where x in meters and t in seconds. Calculate the length of the pendulum. Okay, so be careful with the unit. I always want to emphasize that. Be careful with the unit. Because it gives impacts. When x is in meter, so the amplitude also will be in meter. When time in second, so the omega will be per second. This is very important. Yeah, the unit. If the displacement is in cm, then the amplitude will be in cm. So your answer, your amplitude must give cm. Don't get wrong. All this, yeah. Okay, all right. Now, okay, just want to write again. This is meter, so this meter. And this one is second, so this per second. So I write the unit beside here. See. Now, I want to find the length of the pendulum. So the L. So what I know for pendulum is this formula. Period equal to 2 pi square root L over G. So what I need to find L, so I need to know the period. G is on Earth. This pendulum is surely by default is on Earth, not other planet. By default, okay? It didn't mention at which planet, so it must be on Earth. So on Earth, the gravity should be, 9.81 by default. So I need to find the period. So how to find the period? Which one can give me the period? Yes, the omega. Okay. In fact, this is the amplitude. This the amplitude has no use to me. Okay. The amplitude has no use to me, but the omega. So omega, I can find period because omega is 2 pi over period. 2 pi over period. Is it in the SI unit? Yes, the time in seconds. So my period will be in second also. That's why I need to check the unit. The unit is very important. The time is in second given. Okay. Okay. So my period is 2 pi over 7. What's the unit for my period? Second. Yes, second. Second because it follow the unit of time, second. Okay, given is second. So I got my period. Okay, the unit is in SI unit. I no need to change anymore. It's already in SI unit. So I got my period. I got my period from where? From the omega. Okay. So this is 2 pi. 2 pi over 7 equal to 2 pi square root L over G should be 9.81. Okay, so I just this is the period, can be cut off. And then I solve to get the L. And what is my L? My L is in 0.2 meter. Yeah, that's my L. That's my length. I got it, the answer. Okay? So always compare the equation with the general equation. X is equal to A cos omega t. Understand that? You understand that? So this omega is the 7. This omega is the 7. And then the amplitude is 0.175. Okay, amplitude is 0.175. The omega is 7. So from omega there, I can get period. I can get period. Once I got my period, I got my length using this formula. Okay, very simple. Now, next question. A mass of 0.32 kilogram is attached to one end of the horizontal spring and performs simple harmonic motion on a smooth table. Its displacement equation is given by this. where x in meters and time in second, again, I have nothing to worry because everything still in SI unit. Yeah, meter. So x in meter, the amplitude is meter. So t in second. So the radian, the omega should be in per second. Okay, I have nothing to worry. So I need to find the length. No. I need to find the force constant of the spring, which is the K. To find K for a spring mass system, I can use this formula. Period equal to 2 pi square root m over K. So from here, I can get the K. But I need the mass and the period. So again, to find period, we use the omega. Okay? We use the omega. So again, I compare the formula. Formula given is this 0.2 sine. Yeah, so formula given is that one. So compare with A sine omega t. So yeah, the omega is 8. Okay, the omega is 8. So I can, from the omega, I can get period. 2 pi over period. Okay, this is pi or 8. So, okay, anyway, the unit, just now he give the time in second. Okay, the time in seconds, so omega is per second. Okay, the unit given is time is second, so the omega should be per second. So, all right. So, what is my time? My period is equal to 2 pi over 8. Unit is second, SI unit. Because omega is per second, so the period is second. Okay, so that's in SI unit ready. Okay, good. So I got my period 2 pi over 8, and then 2 pi, and then square root. What's my mass? Yeah, mass just now given. Yeah, you see here? Mass given here 0.32 kilogram. So just use the mass 0.32 kilogram. 0.32 kilogram, and already in SI unit, kilogram. Okay, no need to change. So SI unit. So find my K, spring constant, and what's the answer? Okay, I can cut the common and then find the answer. Spring constant is 20.48. Your unit, because everything in SI unit, so nothing to worry. Spring constant. What's the unit for spring constant? Because we know F equal to Kx, the Hooke's law, isn't it? The Hooke's law. So, the K, this is the spring, force in the spring. K is F over X. So, the unit is, come on, the unit is Newton per meter, right? Hooke's law, Newton per meter. So, the unit for K is Newton per meter. Okay, so that's the answer for K. All right. So, anyways, we have other ways to find the K. Maybe we can use this formula. Okay. We can use this formula, K equal to m omega square. In fact, K equal to m omega square is the same formula with period equal to 2 pi square root m over K. They are same formula. You try to derive this formula to that formula, period. You will get the period formula. Yeah, these two formula is the same. We can use this formula to find K also. Let's try out. We have the mass. K equal to m omega square. M is 0.32 kilogram SI unit. Omega is 8. 8, second. The unit is follow the time. Time is second, so omega is per second. Already in SI unit. So the 8 is already in SI unit second. Okay, nothing to worry. No need to change. So still 8. And you will get the answer 20.48 Newton per meter. Okay. So that's how we do the how we find the length of pendulum and force constant of the spring from the formula. So we just need the omega actually. Okay. We just need the omega. We just need we just need the omega. Okay. We just need the these two. This is the omega, and this is also the omega. From there, we get the period. From there, we get the period. Once we have the period, we can use the formula period equal to 2 pi square root L over G, or period equal to 2 pi square root M over K to find the length, of pendulum, and also the force constant of the spring K. Okay? So we just need the omega, with which is equal to 2 pi over period for both. Very simple, isn't it? Okay, stay tuned for the next videos. Bye.